This is the lesson for Friday, March 17th, 4.8b on bearings. Now, you see three diagrams in the middle of our page here, and the bearing from point O to point P is the acute angle measured in degrees between the ray OP and a north-south line. So in these diagrams, the north-south line you can see is the vertical line, like the y-axis, and you're going to be using that north-south line to find bearings. So in the picture on the far left, when you look at the ray OP, the angle that you're trying to find is the angle measured between that ray and the north-south line. And in that first picture, that angle is 40 degrees. It's given to you. Well, that's the bearing of north 40 degrees east. You see a bearing, if you look down here at the bottom, has three parts. It starts with a letter which is either north or south. That depends when you start at the origin, if you're going up and to the right or up and to the left, down right, down left. But up and down is north or south. Then sandwiched in between the letters north and south and east and west is the measure of an acute angle formed between the ray OP and the north-south line. So north and south is up or down, east and west is right or left. So in the far left diagram, the ray OP goes up and to the right. The up is north, the right is east. You can see that right here. And the angle that's sandwiched in between north and east is 40 degrees because that's the angle formed between the ray OP and the north-south line. Look at diagram B. In the middle picture, the ray OP is up and to the left. Well, up is north and to the left is west. And the angle sandwiched between north and west is 65 degrees. It's the angle from the north-south line to the ray OP. Finally, we have diagram C. In diagram C, the ray OP is in quadrant 4, where you're going down and to the right. Well, down and to the right is southeast, and the measure of the angle sandwiched in between is 70 degrees. Again, that angle is formed with the north-south line. It's not a reference angle. And that angle in this diagram is given as 70. So that's bearing angles. So if you move down to diagram or page 2, you see this diagram on the left, and we're going to take a look there. Now, some of the angles are given to you. You can see the 10 degree, 30 degree, 70 degree, and 20 degree angles already given. In quadrant 1, if the one angle is 10 degrees, that means the other angle is 80 degrees. In quadrant 3, the angle that's given is 70 degrees, which means the angle that's not given is 20 degrees. And we could do the same thing in quadrants 2 and 4 as well if we needed to. So the first question says, what is the bearing from O to B? So I need to find the ray OB, and that's going up and to the left, and up means north, and left means west, and sandwiched in between is that angle that's going from the north-south line to the ray OB. And that angle is given to us as 30 degrees. So that's our bearing. How about the bearing from point O to C? Well, find the ray OC in quadrant 3, and we're going down and to the left. Down is south. To the left is west, so our bearing is southwest, but sandwiched in between is that acute angle that's formed between the ray OC and the north-south line, and that would have to be 20 degrees. So the bearing from O to C is south 20 degrees west. How about the bearing from point O to point D? That ray is in quadrant 4. So the ray OD, you'd have to go down and to the right. Well, down is south and to the right is east. So that bearing would be south. And then sandwiched in between south and east is the measure of that angle, which is again formed between the terminal side, the ray, and the north-south line, and that's 20 degrees. They didn't ask for the bearing from O to A, or sometimes they write it the bearing to A from O. But either way you talk about it, the ray OA is in quadrant 1, where you're going up and to the right. Up is north, to the right is east, and the bearing angle has to be the angle between the north-south line and the ray OA, and that would be this 80-degree angle, which I had to find by taking 9D minus 10, and that's the angle that you want sandwiched between north and east. So those are bearings. You'll have a similar diagram in my math lab. The final page of our notes. Now, this is a diagram that would be drawn normally after reading what the problem says. And what it says is a sailboat leaves the entrance to a harbor and travels 30 miles on a bearing of north 40 degrees east. So my sailboat is right here. Here's my sailboat. And it's going northeast, which would mean up and to the right. So what I do is I approximate that line. I drew northeast, and 40 degrees, like I imagine with like a right angle here, 40 degrees isn't quite halfway. So I drew going the blue line up and to the right, and I drew it any length you want, but I label that 30 miles. Now it stops up here, and then it says the captain turns the boat 90 degrees clockwise, which means when you rotate clockwise, then the boat is going to head in the direction of the red line, which it says travels 20 miles on a bearing of south 50 degrees east. So now I'm going this direction. Southeast means down and to the right. I know 20 miles has to be shorter than 30 miles when I draw my diagram, so I guesstimate. I don't need a ruler and a compass and protractor. I just guesstimate. It's a sketch. So 20 miles is going to be shorter than my 30 miles in blue. And I stopped here, and you can see my boat. And then it says, at that time, how far is the boat from the harbor entrance? So the harbor entrance, that's H. In my original diagram, that's H, and that's right here. And that was my boat. So how far is the distance? And I called that C here. Now notice I have two north-south lines because they gave me the bearing of my boat in red as south 50 degrees east. So when I drew that north-south line, that 50-degree angle is right here, formed with the red segment and the north-south line. Now that's useful for knowing that the other part of that right angle is 40 degrees, which may or may not necessarily come into play when you're solving the problem. So now it says, what is the bearing of the boat from the harbor entrance? Well, let's tackle the first problem. How far is the boat from the harbor entrance? Well, I can actually just use Pythagorean theorem. You can see in part A here, I did 30 squared for the 30 miles plus 20 squared for the 20 miles. It's a right angle there, and that has to equal c squared. And you can see 900 plus 400 would give us c squared equals 1300. We take the square root, and that's about 36.1 miles. So that's the first question. How about the second question? Well, the second question says, and I'm going to change to black, what is the bearing of the boat from the entrance. Now, the bearing of the boat from the entrance is the north-south, it's the angle formed with the north-south line and the line that is connecting the harbor to the boat. And that would be made up over here, when you look at the diagram, of the 40 degrees from the original bearing angle when we left the harbor, plus the angle theta down here in my triangle. So I have a right triangle, and I'm suggesting in part B here that the tangent of theta, the tangent of that angle, has to be the opposite side over the adjacent side of that right triangle, which is 20 over 30, or 2/3 when you reduce. All I need to do then is use the inverse tangent, make sure your calculator's in degree mode, and find the angle that has a tangent value of 2/3 or 20 over 30, and that is 33.7. So what I need to do is add 40 and 33.7 together to get the bearing angle of 73.7 degrees, and that's this angle right here. And the boat from the harbor is up and to the right, which would be northeast. All right. So what you need to do is try your MyMathLab assignment 4.8b. And there may be a couple problems where you have to draw with bearings that are a little tougher. So do your best to look at the example and try to draw a picture. But if you have trouble, we'll take a look at that on Monday when I return. Have a great day. Hope all is going well. See you then.